Alright, welcome back. In this video, we're going to go over part 2 of the Pyruvate Dehydrogenase Complex. So, I can't believe I have to say this, but if you have not watched the last video, which is part 1 of this Pyruvate Dehydrogenase Complex, please watch that first, because this video is going to make absolutely no sense. Anyways, so where we left off was with this lipoamide molecule that happens to be fully reduced. That's not a good thing. We need to oxidize it. So here's what's going to happen. We have this cofactor here. This FAD cofactor attached to a cysteine molecule is basically going to steal the protons from the lipoamide molecule. That's it. So using this enzyme, dehydrogenase, it's going to facilitate the transfer of the protons from the lipoamide onto the cysteine residue on the FAD molecule. So that means the FAD molecule becomes fully reduced to FADH2, and the lipoamide returns to its oxidized state, which was what I introduced here, right? From the first video, from part 1. That's it for step 4. Step 5 is a little mysterious. And the reason is because usually in biochemistry, and usually in your body, and all the evidence that's been found, normally NADH transfers its protons to FAD. That is like 99% of all cases. This is the one exception. For some reason, what researchers have found is that this FAD residue, or FAD cofactor, with its cysteine counterpart here, is actually transferring the protons onto NAD+. And this is causing a fully reduced form of NADH plus H. This is very unusual because this hardly happens. This is like the only instance that this actually happens. Usually, because like I said, usually it's the other way around in that the NADHs would give its protons to FAD. So on the MCAT, if you were ever asked if NADH is giving its protons to FAD or the reverse, almost 99% of the time it's NADHs that are giving it to FAD and not this, what I'm showing you here. But for this complex and what we know about biochemistry in this pyruvate dehydrogenase complex, this is how it works. So, once again, we are transferring the protons onto NAD+, becoming NADH plus H, become fully reduced. And then this cysteine sulfurs attached to the FAD are fully oxidized. And this concludes the pyruvate dehydrogenase complex. If you found this video helpful, please like and subscribe. Until next time, later.